Hello guys, in this video we'll work on the implementation of stack data structure using singly linker list as the underlying data structure. So it will be the implementation will be singly linker list based stack implementation, and let's dive into that. So as long as we are using a single linker list, we are required to define a node with an info and next attribute, a node with info and next attribute. Okay, let's call the class node and defining info in next okay. For your information, this is the board me coding. I'm coding in a board mode. No, okay, let's define a constructor which can accept both int and both info and next as para. So how long is this going to take me? Let's see this public class, public node int info, then node next, and I say both this dot info will be equal to info this dot next, say to next. Let's define another which can accept info as the only parameter. Public overloaded constructor and int info, and let's set this info, and next will be set to now. So now we are done with our node definition. Let's go to our stack. A singly linked list based stack implementation. In this class we will implement the following method. Will implement the first one is a method to check if the stack is empty or not. The second one is a method to check if the stack is full or not. A method to push an element to this stack a method to check, a method to pop an element from top of the stack. In the fifth one, method to check what is the top of the stack. In the sixth one, a method to return, a method which can return the number of items in the stack, in the stack. It is a stack, not sack. Okay, saying this about what we are going to implement, let's define our stack. Okay, defining the top of the stack, a pointer to the top of the stack. Okay, a variable which can store the size of stack. Okay, those things, let's private, those things can be private. Top, I mean int size. Hey, if you can write this fast, that means you can watch the last episode of Peaky Blinders. So go Ephraim, go. Did I say my name here? Oh god, that's going to be, which can store the number items or elements in the stack. Okay, private int items or items. Oh, and that's fine. Then let's define a constructor. Let's a constructor. This will accept stack int size, and let's this dot size will be equal to size. Let's check for implement, check for a method, method which can stack it empty or not. That's just a very simple method, public boolean is empty, and this is a very simple method. Return this dot top equals null. If our top is null, that means our stack is empty. A method which can check if this stack is full or not. Public boolean is full. This is also a very simple one. This dot size, this dot items equals this dot size. If the item is, the number of items is equal to the size of the stack, that means our stack is full. Okay, let's return the number of current items in the stack. Okay, public int items count, okay, let's return this dot items. Okay, now let's implement a method which can push to the top of the stack. Public, and it's gonna return a boolean. Okay, if push, then int info, the information that we are going to push. Then let's first check if the stack is not full, will push. If the stack is not full, will push. If the stack is not full, this dot is full, will push. Else will return false. I mean, we're not able to push. This means return false if the stack is already full. Then if the stack is empty, pushing to an empty stack. Then let's create our node here at the top. Node, new node, then info. Then this dot top will be equals this node. This node, pushing a non-empty stack, then else, which is this dot, node dot next will be set to this dot top, the current top, then this dot top will be updated to this newly created node. Then in both cases, this dot items will be increased by 1 and will return true. That means we are increasing, the items will be updated, and initially let's set the items to 0, now this is it. Okay, then a method the top of the stack, the top the stack boolean, then let's pop it, and we are not going to accept any element here. Then if the stack is not empty, else this is empty. If it is not empty, if our stack is not empty, then okay, else then we'll return false. We are not popping anything. So if the stack is empty, if it's not empty, this dot top will be equal to this dot top dot next. So this will be the case. Okay, here we can yeah, that's fair, that's fair enough. Otherwise, then we'll set this dot items minus equals 1. We'll decrement our item by 1 and we'll return false. Okay, now we are done. We are done with the push and pop. Okay, let's implement another method which can check the top of our stack. Okay, okay, the top of this stack. Okay, let's give it a name. Our return type would become let's check then a convenient name for it. Let's just give it a top element. Okay, and top element. Okay, if the stack, check if the stack is not empty. If not, this dot is empty. Return this dot top dot info. Otherwise, we'll return -1. I mean, that means there is no element at the top. This will return -1. If it's -1, we'll yeah, let's do it like that. Okay, now we're done. Vim test stack .java. Okay, here we will test our stack implementation. Okay, yeah, I might make a lot of mistakes. Test stack. Oh, this is a class, right? What am I writing here? I really don't know. Public static void main string stack new stack, and let's set the size for stack dot push. Let's push 4. Okay, stack push 5. Then let's system dot out dot print line the top of the stack is the stack dot top element. Okay, now let's compile this. Oh, there is no mistake at all. Come on. The top of the stack is 5. Oh my god. Like this is working like this. Let's pop here the top dot pop. Now the top of the stack is 4. God, it's working. You can check other current element. The number of elements in the stack is stack dot items count. Yeah, it's 1. Let's add 1 here. Let's push 2 more. System dot out dot print line. Oh no. Stack dot push 7. Stack dot push 8. Stack dot push 9. Okay, now we have stack dot push 11. Now we have okay, now we have the number of elements is 5. Let's add one more since the size is defined 5. If we added 1 in, the size has to remain at 5. Like, since the stack is full now, will not be allowed to add additional element to it. Push 13. Yeah, so it's not adding a 6 element. So we are done. Thank you for your attention. I know this is a very boring video. It's because I'm bored, like I just want to get it done. That was the only motivation. So thank you and have a good time. Thank you for your attention.